Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximize, minimize, and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Welcome back to part 2 of Microsoft Azure Virtual Training Day Azure Fundamentals event. In this second part, we'll cover the last 3 sessions, starting with session 4 on Azure Storage. In session 5, we'll explore Azure Identity, Access, and Security, and Azure Cost Management. And then finally, we'll wrap up part 2 and the event with session 6, where we'll cover Azure Governance and Compliance, Azure Resource Management, and Azure Monitoring Services. With that, let's get started with session 4 on Azure Storage. In this session, we'll focus on exploring storage and its options with Microsoft Azure. More specifically, we'll introduce what storage services are, followed by storage redundancy configuration options, and how those options map to the physical infrastructure. We'll also give an overview of some of the different storage services and common configuration options in Azure. And then lastly, we'll review some of the ways we can handle data migration and file management for our data held in Azure Storage accounts. So let's get going on our learning objective for this session on Azure Storage. Azure Storage accounts are essential for storing data in the cloud. They provide a unique namespace for your Azure Storage data objects, which include blobs, files, queues, and tables. This unique namespace ensures that your data is accessible from anywhere in the world over HTTPS or HTTP if you decide to enable it. Data in your storage account is durable, highly available, secure, and massively scalable. Each storage account must have a globally unique name, ensuring that it can be accessed without any conflicts. These accounts provide over-the-internet access worldwide, allowing you to store and retrieve data from anywhere. When setting up a storage account, you can determine the storage services and redundancy options that best suit your needs. This includes choosing between different types of storage, such as blob, file, queue, and table storage, and selecting redundancy options like locally redundant storage, zone redundant storage, geo-redundant storage, or read-accessible geo-redundant storage. These options ensure that your data is stored securely and can be accessed reliably, even in the event of hardware failures or other issues. Not all file access is for users, and a simple example of this would be in the context of a web application that needs to store and serve large amounts of unstructured data, such as images, videos, and documents. Because of these different scenarios, we need to think about how our storage account needs to serve the data to users or applications. As I mentioned previously, you need to configure how your storage account will manage redundancy. So let's compare the different configurations. Local redundant storage, or LRS for short, replicates your data 3 times within a single data center in the primary region. This is the most cost-effective option, but may not provide sufficient protection against data center level failures. Zone redundant storage, or ZRS, replicates your data synchronously across 3 Azure availability zones within the primary region, offering higher availability and durability by protecting against data center level failures. Geo-redundant storage, or GRS, replicates your data to a secondary region more than 300 miles or 500 kilometers away from the primary region where your data was originally written. This ensures that your data is protected against regional disasters. Geo-Zone Redundant Storage, or GZRS, represents the high availability provided by redundancy across availability zones with protection from regional outages provided by geo-replication. In GZRS, your data is copied synchronously across 3 availability zones in the primary region using zone redundant storage, and then replicated using geo-redundancy to another region. This ensures that your data remains available even if one of your availability zone experiences an outage or if the entire region were to fail. Any of the geo-redundant options can also be configured as read accessible, which will provide the same level of protection as GRS or GZRS, but also allows read access to the data in the secondary region, ensuring that your synchronized data will remain available even if the primary region becomes unavailable. Storage durability refers to the ability of the storage system to protect data from loss or corruption. Azure Storage ensures durability by maintaining multiple copies of your data across different hardware and different locations, depending on the redundancy option that you choose. This means that even if one copy of your data is lost or corrupted, other copies are still available, ensuring that your data remains intact and accessible. With these redundancy options, the durability of your data increases as you go to higher redundancy levels. So for local redundant storage, the durability starts at 11 nines, or 99 point followed by 9 nines %, right? That's huge. Zone redundant offers 12 nines, so 99 point and 10 nines. And geo-redundant options offer an amazing 16 nines of durability, which is amongst the highest in the world. I think that's a pretty good guarantee of ensuring that your data is protected. Let's take a closer look at how these redundancy options manage their copies across the physical infrastructure in Azure. On the slide here, there are 2 regions, and if you recall, these would be paired regions. So they would be physically separated by at least 300 miles or 500 kilometers. We're also showing 3 data centers in the first region. These would also be considered availability zones, since the 3 data centers are within the same region. Also, as a side note, many of our regions have more than 3 data centers in them, but when it comes to availability zones, we focus on 3. The first example shown here is LRS, or locally redundant storage, where 3 copies of the data are managed within a single data center. These 3 copies are written to like a 3-way mirror with no shared hardware between any of the copies. This is better than having one copy written and then replicated. By using a mirroring approach, we can keep those durability numbers that we just talked about nice and high. All right. This is essentially the minimum data redundancy standard that we use for all services in Azure. Many services actually go higher than this. For zone redundant storage, those 3 copies are spread across the data centers and are still managed like a 3-way mirror where all of the data is synchronized. So when you create a file, for example, all 3 copies are written to synchronously. In this case, across the 3 data centers. Because the same data exists across the different data centers, if an entire data center should fail, your data would still be accessible. Next, we have the geo-redundant example, where we have 3 copies of the data in one region, which is written to synchronously. And then we have another 3 copies of the data in a different region that is more than 300 miles or 500 kilometers away. Because of the distance, and this is really a physics issue, the data will be written to the other region asynchronously, which means there will be a slight latency delay between the regions. This would help protect your data in the event that an entire region should fail, such as from a natural disaster. And remember that this level of redundancy has 16 nines of durability, or 99 point followed by 14 nines. That's the percent for the durability. You might be wondering though, what if data center 3 here were to fail? Wouldn't we lose all 3 copies of our data in region 1? Possibly. But for that, we have geo-zone redundant storage, which keeps the 3 copies in the first region separated by zones, and then a separate 3 copies replicated in the secondary paired region. Basically, we're simply combining zone redundancy with geo-redundancy. We also need to consider how people or applications will use the data that's stored within the storage account. Each of these options change the behavior and capabilities of how your data is managed within the storage account. For example, these different types can change the protocols that are used to access the data, or the way that the data is organized within the storage. Keep in mind that not all data is accessed by people. Most of it is accessed by other services and or applications. Let's break down the different types. Azure Blob Storage is designed for storing large amounts of unstructured data, such as text or binary data. It's ideal for serving images or documents directly to a browser, storing files for distributed access, and streaming video and audio. This is a common type used by applications. Azure Disk Storage provides persistent, high-performance disk storage that are used by Azure virtual machines. It offers different types of disks, including standard HDD, standard SSD, and premium SSD to meet various performance and cost requirements for virtual machines. Azure Queue Storage is a messaging service that enables communication between different components of an application. It allows you to store large numbers of messages that can be accessed from anywhere in the world, ensuring that your application components can communicate to each other reliably and asynchronously. Azure Files offers fully managed file shares within the cloud that are accessible via the SMB protocol. This makes it easy to migrate legacy applications that rely on file shares over to Azure without changing the code. Azure Files also supports something called Azure File Sync, which allows you to cache and synchronize your on-premises file shares with Azure file shares within the cloud. Lastly, Azure Table Storage is a NoSQL key value store for rapid development using massive semi-structured data sets. It provides a schema-less design, making it easy to adapt as your application evolves. It's perfect for scenarios where you need to store large amounts of structured data or semi-structured data that can be queried quickly. An example of this could be an application needing to store table-like data. In order to access these different storage services, people, services, or applications will need to use the appropriate endpoint, depending on what type of service is being used. This provides a way of connecting to the service, as well as helping to connect to the correct type of service. For each of these services, you'll notice that the public endpoint will be a little bit different based on the type. For example, for accessing blob storage, the endpoint is https:// the name of your storage account, dot, followed by the word blob, followed by core.windows.net. For the Data Lake Storage Gen 2 type, the URL has the word DFS in it. For Azure Files, it's file. For queue storage and table storage, their URL will have the word queue or table in it respectively. Another configuration option when we're managing our data in Azure is to consider the access tier that we need to use to store our data. Access tiers help you manage costs based on how frequently your data is accessed and how long it'll be retained. These costs can be broken down into the storage cost, which is the cost to keep the data there, and the access cost, which is the cost to read or write that data. Overall, these are relatively cheap costs, but we need to select the appropriate access tier for our use case to minimize these costs. Starting with the hot tier. The hot tier is designed for data that is accessed or modified frequently. It has the highest storage costs, but the lowest access costs, making it ideal for active data. The cool tier is optimized for data that is infrequently accessed or modified. It has lower storage cost and higher access costs compared to the hot tier, making it suitable for data that you don't need to access often, but you still want to keep readily available. Data needs to be stored in this tier for at least 30 days to get the full benefit of the discounted pricing. The cold tier is for data that is rarely accessed or modified, but still requires that fast retrieval. It has even lower storage cost and higher access costs compared to the cool tier, making it a cost-effective option for data that you need to keep but really don't access frequently at all. Data should stay in this access tier for at least 90 days to get the full benefit of the discounted pricing. Finally, the archive tier is for data that is very rarely accessed and has flexible latency requirements. It has the lowest storage costs by far and the highest access costs, making it ideal for long-term storage of data that you don't need access to immediately. Data in the archive tier should remain there for at least 180 days to get the full discounted price as well. You might be thinking that the archive tier sounds ideal to store backup data since it's cheap and designed for long-term storage, but you should think of this tier more for storing data required to meet compliance standards and only being retrieved, for example, when the lawyers show up. For backups, there's a dedicated Azure backup service specifically designed for storing and retrieving backups, including storing them for long term. So let's do a demo so we can get a better feel for how Azure storage works. All right, so in this demo, what we're gonna do is we're gonna go and provision a storage account. And since the other ones I did bash, I'm gonna do this in the interface again. So let's go and create a storage account. Let's search for it. So just under create a resource, there's storage accounts. And on this list, let's close that. On this list, we see storage accounts from Microsoft. That's the one we're looking for. Lots of resources. And I'm just going to start off with creating this, right? So click on the create. And we won't go through all of the settings on this, so this is going to be pretty simple. Subscriptions, it's how we pay for the service, the resource group that we want it to belong to, so we'll put it in the Azure demo one, and we're going to give it a name. So let's do something like Azure Demo. Oh, actually, let me change that. It needs to be lowercase, right? So Azure Demo storage account, and it also has to be unique, right? So apparently somebody already has that, as well as with the 2 at the end. Let's see if we can. Oh, it's a little too long. All right. Let's just modify a little bit of this. Let's try a different name. So, the real world, we do want these to, be very unique. So how about Azure Demos storage? Perfect. All right. So that looks like it's an approved name. It's not in use. So we'll use that one. Coming down a little bit, where in the world this is going to exist. So Canada Central is fine for me. That's closer to where I'm at. The redundancy that we talked about. So we're going to switch this to locally redundant storage, just one of our simplest ones. There's a lot more of the settings, but again, this is just an intro. So I do need to make one little change here. I'm going to enable this. The allow enabling anonymous access on individual containers. So normally from a security perspective, we can go the other way, but we're going to allow this just so you can see a very simple demo here that we can access the something from the blob storage. All right, so everything else, we're going to take the defaults. Let's go right to the review and create page so we can see this. And This looks good. So let's hit the create. And we're submitting the deployment over to the resource manager in Azure, which is going to make sure this happens. And this shouldn't take too long. To go and create this storage account, we can see it in here. And this will return back when it's done. So here it is. It's been accepted. It's currently, going through that provisioning state. Storage accounts go fairly fast, so this should just be a few seconds. There we go. Deployment succeeded that fast. So let's jump to this resource. And what we're going to do is just show you that it actually is storing things. So coming down a little bit, under the data storage section, we have everything in our storage account is kind of stored in these different ways, right? So we have like containers and file shares and queues and tables that we're talking about. For this one, I'm just going to do something simple with a container, right? And so let's go and create a container. A lot of people, kind of say, well, these are very similar to like folders. Not really, but yeah, I get it. It's a way of containing a bunch of blobs in here. So let's give it a name. How about just Azure demo for the container? We'll kind of stick with that theme. And we can do a lot of things. The anonymous access level, I just want to point out that I'm leaving this to private. I could change it here, but and we're going to do this in a little bit. But right now, I'm going to leave this set to private, right, for this. And we'll do the anonymous stuff in just a second. I want to show you that this actually doesn't work. So private, let's hit the create button. And let's go into our container and we're going to upload a file in here. So once we're in here, let's go to the upload. And I'm going to go grab an image real fast and drag it in here. There we are. As notice, a happycloud.jpg. It's all about the happy clouds. And that's it. It's uploaded. Right now, if we go into this, we can go and grab the URL for this. And so we're going to copy it. And you don't see it right here. That's just masked out. It's a tool that we tend to use to keep some things private. But you see the URL that I'm using right here. And you notice that when I try and go to it, because I'm not authenticated over this URL, it actually tells me it doesn't exist. It does. The URL is correct. It's just telling me like, no, I don't know what you're talking about because I really don't have permissions to it. So what I'm going to do is I'm going to go back and I'm going to change the access, that anonymous level access. I'm going to change that so that's going to be supported. So let's go back to our container, right? Back to our container, and I'm going to change the access level for this. So this is what I was talking about earlier. Let's come down to blob anonymous read access for blobs only. And I'm simply going to change this on this container. Now, this is an option. We can make these incredibly secure, incredibly private. In this case, I'm going the other way and enabling anonymous access to it. So that's all I did. I'm just simply going to go back to this URL and just hit the refresh button. And ta-da, there's the happy cloud, right? Looks like a very, so generated by Copilot, but there's our happy cloud, the image in our, that file content that we have in our storage. So this works. There's a lot more going on with storage, but for now, let's go back to our content and continue on with our fundamentals course. Now let's talk about Azure Migrate. Azure Migrate is a unified migration platform that simplifies the process of moving your on-premises workloads to Azure. It offers a full range of integrated and standalone tools to support different migration scenarios, ensuring a smooth transition over to the cloud. The platform provides comprehensive assessment and migration capabilities, allowing you to evaluate your existing environment, identify dependencies, and plan your migration strategy effectively. With Azure Migrate, you can assess your on-premises servers, databases, web applications, and virtual desktops, and then migrate them to Azure with minimal disruption. The platform also supports continuous discovery and assessment, helping you to keep track of your migration progress and make informed decisions throughout the process. Azure DataBox is a cloud solution that lets you send terabytes of data into and out of Azure quickly, inexpensively, and reliably. The secure data transfer is accelerated by shipping you a proprietary DataBox storage device. Each storage device has a maximum usable storage capacity of 80 terabytes and is transported to your data center through a regional carrier. And the device has a rugged casing to protect and secure data during transit. You can order the DataBox device via the Azure portal to import or export data from Azure. Once the device is received, depending on whether you'll import or export data, you'll copy the data from your servers to the device or vice versa and ship the device back to Azure. If importing to Azure, in the Azure Data Center, your data is automatically uploaded from the device to Azure into one of your storage accounts. The entire process is tracked end-to-end by the DataBox service in the Azure portal. DataBox is ideally suited to transfer data sizes larger than 40 terabytes in scenarios with no to limited network connectivity. The data movement can be one-time, periodic, or an initial bulk data transfer followed by periodic transfers. Who knows? For example, you can use DataBox for a one-time migration when a large amount of on-premises data is moved to Azure. DataBox can also be used to export large amounts of data of your data from Azure to your on-prem environment. And there's even a larger option called Azure DataBox Heavy if you need to move up to a petabyte of data. Managing files in Azure storage can be done efficiently using several tools. The speed and effectiveness of these tools will usually depend on the amount of bandwidth that you have between your environments. The first tool on the list, AZ Copy, is a command line utility that allows you to copy data to and from Azure storage. It's perfect for transferring large amounts of data quickly and reliably. You can use AZ Copy to move files between storage accounts, upload files from your local machine to Azure, or even synchronize files between different storage locations. Azure Storage Explorer is a graphical tool that provides a user-friendly interface for managing your Azure storage accounts. With Storage Explorer, you can easily upload, download, and manage files in your storage accounts. It also supports various storage types, including blob, file, queue, and table storage, making it a really versatile tool for all of your storage management needs. And lastly, Azure File Sync is a service that allows you to centralize your file shares in Azure while keeping the flexibility, performance, and compatibility with an on-premises file server. With Azure File Sync, you can synchronize your on-premises file shares with Azure files, enabling users access to the local on-premises file server, which is then synchronized with Azure files in the cloud, completely transparent to the user. It also provides cloud tiering, which automatically moves infrequently accessed data to the cloud, freeing up the space on those local servers. That brings us to the end of our session on Azure Storage. In this session, we covered what Azure Storage is. We then discussed the different redundancy options that are available to storage accounts, and then wrap things up with the different ways that you can migrate your files to and from Azure, as well as manage your files once they're in Azure. This concludes session 4. We'll take a quick 10-minute break before starting with session 5 on Azure Identity, Access and Security, and Azure Cost Management. Have a great break and see you back shortly. Welcome back. I hope everyone had a great break and are ready to start session 5 on Azure Identity, Access and Security, and Azure Essentials Cost Management. In this session, we'll be covering the following learning objectives: Azure Identity, Access and Security, where we'll introduce directory services, authentication methods, and security models. And then we'll cover Azure Essentials Cost Management, where we'll introduce the cost and pricing calculators and discuss cost management and resource tags in Azure. So let's get started with our first learning objective on identity, access, and security. First, it's important to understand what an Azure tenant is. An Azure tenant is a dedicated and trusted instance of Microsoft Entra ID that's automatically created when your organization signs up for a Microsoft Cloud Service subscription, such as Microsoft Azure, Microsoft Intune, Office 365, or perhaps Dynamics 365. Essentially, an Azure tenant represents a single organization and serves as the backbone for managing identities and access to various resources within the Azure ecosystem. So Microsoft Entra ID is Microsoft Azure's cloud-based identity and access management service. It serves as the cornerstone of authentication in Microsoft Azure, supporting various essential functions. First, it handles authentication, allowing employees to sign in and access resources seamlessly. This is crucial for maintaining security and ensuring that only authorized personnel can access sensitive information. Additionally, Microsoft Entra ID supports single sign-on, which simplifies the user experience by enabling employees to access multiple applications with a single set of credentials. This not only enhances productivity, but also reduces the burden and increases security compared to managing multiple passwords. Application management is another key feature of Microsoft Entra ID. It allows administrators to manage access to various applications, ensuring that users have the right permissions based on their rules. This is particularly useful for maintaining security and compliance within the organization. Furthermore, Microsoft Entra ID facilitates business-to-business collaboration by allowing external partners to access resources securely. This is essentially for organizations that want to work closely with vendors, contractors, or other external entities. Device management is also supported by Microsoft Entra ID, enabling administrators to manage and secure devices that access the organization's resources. This ensures that all devices comply with security policies and helps protect against potential threats. Microsoft Entra ID focuses on authenticating users and services with what is referred to as claims-based or modern authentication. This is different than the traditional method of authentication that the on-premises version of Active Directory used. However, Microsoft Entra ID also supports Microsoft Entra domain services. If you need to support applications or services that require those traditional authentication protocols, specifically Kerberos and/or NTLM. Microsoft Entra Domain Services can also provide other managed domain services, such as domain join and group policy support. One of the key advantages is the ability to run legacy applications in the cloud, particularly those applications that can't use modern authentication standards. This allows you to lift and shift those applications from your on-premises environment into a managed domain hosted by Microsoft without needing to manage your own Active Directory domain services infrastructure inside of the cloud. This way, you can gain the benefits of using cloud-based domain services without the need to deploy, manage, or patch domain controllers. So you can focus on your core business activities while Microsoft handles the infrastructure. Additionally, Microsoft Entra Domain Services can be configured to automatically sync from Microsoft Entra ID. This integration lets users sign in to services and applications connected to their managed domain using their existing credentials. It also allows you to use existing groups and user accounts to secure access to resources. We can also use Microsoft Entra Connect Sync to provide a smoother lift and shift of on-premises accounts by synchronizing our on-prem user accounts with Microsoft Entra ID in the cloud. This can further enhance the single sign-on experience for users while you are migrating your on-prem services to the cloud. Authentication and authorization are two fundamental concepts in identity and access management. Authentication is the process of identifying the person or service seeking access to a resource. It involves requesting legitimate access credentials, such as usernames and passwords, to verify the identity of the user. This process forms the basis for creating secure identity and access control principles, ensuring that only the authorized individuals can access sensitive information. Once authentication is complete, authorization comes into play. Authorization determines the level of access an authenticated person or service has. It defines which data they can access and what actions they can perform with it. For example, an authenticated user might have access to certain files but not edit them. Or they might be able to access specific applications but not others. Together, authentication and authorization work to secure resources by first verifying the identity of users and then controlling their access based on their permissions. Multi-factor authentication, or MFA, is a security measure that requires users to provide multiple forms of verification before gaining access to a resource. This approach enhances security by ensuring that even if one factor is compromised, the additional factors will provide an extra layer of protection. A factor can be of different types. For example, a factor could be something that you know, such as a password or the answer to a security question. This is one of the most common forms of authentication and is something that the user must remember. A factor can also be something you possess. This can be a mobile app that receives a notification or a token generating device. For example, when you try to sign in, you might receive a notification on your phone asking you to approve the sign-in attempt. Alternately, you might use a physical token that generates a unique code you need to enter. Another type of factor can be something that you are, which typically involves biometric properties. This could be a fingerprint, a face scan, or even voice recognition. Many modern devices like smartphones use biometric authentication to provide a quick and secure way to verify your identity. By combining these factors, MFA significantly reduces the risk of unauthorized access. Even if someone managed to steal your password, they would still need to have your phone or be able to replicate your fingerprint to gain access. This layered approach makes it much harder for attackers to compromise an account and ensures that your data remains safe. Microsoft Entra External ID, business to business, or B2B for short, is a feature that allows organizations to collaborate securely with external business partners. It enables you to invite external users to sign in to your Microsoft Entra organization using their own credentials, so they can access the apps and resources you want to share with them. This means that your partners can use their existing work, school, or social identities to access your resources without the need for you to manage their accounts or manage their passwords. One of the key benefits of Microsoft Entra External ID B2B is that it simplifies the process of collaborating with external partners. You can easily invite guest users from the Microsoft Entra Admin Center and manage their access to your resources. This ensures that your corporate data remains secure while allowing your partners to work seamlessly with your organization. Additionally, Microsoft Entra External ID B2B supports cross-tenant access settings, which gives you granular control over how other organizations collaborate with you. You can define inbound and outbound access settings to specify which users, groups, and applications can access your resources and vice versa. This flexibility allows you to tailor your collaboration settings to meet your specific needs. Furthermore, Microsoft Entra External ID Business to Business integrates with other Microsoft services, such as Microsoft Teams, to provide a seamless collaboration experience with those tools. For example, with B2B Direct Connect, users from both organizations can work together using their home credentials, so each person's organizational credentials, and a shared channel in Teams without having to be added to each other's organizations as guests. This mutual trust relationship enhances collaboration and productivity. Microsoft Entra External ID B2B is a powerful tool for managing external collaboration, providing secure access to your resources, and simplifying the process of working with external partners. Microsoft Entra also supports business to consumer or B2C identities. Supporting B2C external identities is done differently than supporting B2B identities. B2C is supported by creating a dedicated external tenant that stores your customer credentials and profile data. And this tenant is separate from your internal Entra ID tenant and organizational resources. This way, we can better ensure that customer data is managed securely and independently. B2C supports various sign-in methods, including username and password, one-time passcodes, and social identities from providers like Google and Facebook. This flexibility allows for you to cater to the preferences of your users, such as customers, making it easy for them to access applications that maybe were designed for your customers to access. The modern security perimeter now extends beyond an organization's network to include user and device identity. Organizations can utilize those identity signals as part of their access control decisions. Conditional access is the tool used to bring these signals together, making decisions and enforce organizational policies. It is at the heart of the new identity-driven control plane. Conditional access policies are essentially if-then statements. For example, if a user wants to access a resource, then they must complete an action. So for an example, we could be a payroll manager wanting to access the payroll application and then being required to perform an action to perform multi-factor authentication to gain access. These if-then statements can include various signals such as user or group membership. Policies can be targeted to specific users and groups, giving administrators fine-grained control over their access. For instance, you might have a policy that applies only to the members of the finance department. IP location. Organizations can create trusted IP address ranges that can be used when making policy decisions. For example, you might allow access only from a specific geographic location or block access from certain countries. Device. Users with specific types of devices or devices marked with a specific state can be used when enforcing conditional access policies. This can include ensuring that only compliant devices or those that meet certain security standards can access the resources we specify. Application. Users attempting to access specific applications can trigger different conditional access policies. So for example, accessing a sensitive application might require additional authentication steps like performing multi-factor. And lastly, risk detection. Real-time and calculated risk detection can be used to identify and remediate risky users and sign-in behavior. This includes integrating signals from Microsoft Entra ID protection to detect and respond to potential threats. Administrators really have two primary goals here: to empower users to be productive wherever and whenever, and to protect the organization's assets. By using conditional access policies, you can apply the right access controls when needed to keep your organization secure while staying out of your users' way when not needed. Role-based access control, or RBAC for short, is a method of regulating access to resources based on the roles of individual users within an organization. In Azure, RBAC helps manage who has access to Azure resources, what they can do with those resources, and what areas they have access to. This system is built on Azure Resource Manager and provides fine-grained access management to Azure resources. The way you control access to resources using Azure RBAC is by assigning Azure roles. A role assignment consists of 3 elements: security principal, role definition, and scope. The security principal is an object that represents a user, group, service principal, or managed identity that is requesting access to the Azure resource. The role definition is a collection of permissions, typically called a role, which lists the actions that can be performed, such as read, write, and delete. Roles can be high level, like owner, or specific, like virtual machine reader. If the built-in roles don't meet the specific needs of your organization, you can also create your own custom roles. Scope is the set of resources that this applies to. When you assign a role, you can further limit the actions allowed by defining a scope. This is helpful if you want to make someone a website contributor, but only for one resource group. In Azure, you can specify a scope at 4 levels: management group, subscription, resource group, or on the individual resource. RBAC provides a simple, manageable approach to access management that is less error-prone than individually assigning permissions. It allows you to grant access to data and applications needed to fulfill job requirements, while minimizing the risk to unauthorized access to sensitive information. By using RBAC, you can protect critical data, improve operational efficiency, and help achieve regulatory compliance. Defense in depth is a security strategy that employs multiple layers of protection to safeguard data and resources. In Azure, this approach is designed to slow down and mitigate the impact of potential attacks, ensuring that if one layer is breached, subsequent layers continue to provide that protection. Since Microsoft manages the physical security to Azure, the first layer of defense that you need to manage is identity and access management. By using tools like Microsoft Entra ID, you can ensure that only authorized users have access to your resources. This includes implementing multi-factor authentication to add an extra layer of security. Next, network security plays a crucial role. Azure provides features like network security groups and Azure Firewall to control and monitor traffic to and from your resources. These tools help to block unauthorized access and protect your network from potential threats. Application security is another important layer. By using services like Azure Security Center, you can continuously monitor your applications for vulnerabilities and apply security best practices. This helps to ensure that your applications are secure and compliant with industry standards. Data protection is also a key component of defense in depth. Azure offers encryption for data at rest and in transit, ensuring that your data is protected from unauthorized access. Additionally, Azure Key Vault helps you manage and secure your cryptographic keys and secrets. Finally, monitoring and threat detection are essential for maintaining a secure environment. Azure Sentinel and Azure Monitor help to provide comprehensive monitoring and alerting capabilities, allowing you to detect and respond to potential threats in real time. By implementing a defense in-depth strategy in Azure, you can create a robust security posture that protects your resources from a wide range of threats. Next, let's talk about Zero Trust. Zero Trust is a security strategy that assumes breach and verifies each request as though it originated from an uncontrolled network. Instead of believing everything behind the corporate firewall is safe, the Zero Trust model teaches us to never trust, always verify. The core principles of Zero Trust include verifying explicitly, using least privileged access, and assuming breach. Verifying explicitly means always authenticating and authorizing based on all available data points, such as user identity, location, device health, and the service or workload they're doing. Using least privilege access involves limiting user access with things like just in time and or just enough access. Risk-based adaptive policies can be included, as well as data protection layers. Assuming breach means minimizing the blast radius and segmenting access, verifying end-to-end encryption, and using analytics to get visibility, drive threat detection, and improve defenses. At Microsoft, we truly believe that security is our top priority. One of the key security services that you can leverage to protect both your cloud and on-prem assets is Microsoft Defender for Cloud. This unified infrastructure security management system not only provides advanced threat protection, but also strengthens the security posture across both Azure and on-prem environments. Microsoft Defender for Cloud continually assesses your resources for security issues, so it can provide security recommendations, detect and block malware, analyze and identify potential attacks, and can offer just-in-time access control for network ports. Defender for Cloud not only shows you recommendations to make your assets more secure, but it can also raise security alerts to help your organization to be more readily able to respond to those various threats. Everything in Defender for Cloud operates at cloud speed. Its native integration ensures that deployment is seamless, including support for auto-provisioning to Azure services. Defender for Cloud also aggregates all of its findings into a single secure score. A secure score is a single number that represents the overall security profile of all of your assets put together. By reviewing the recommendations to improve your score, you can more easily understand your current security situation and take any of the necessary actions to improve it. Remedying issues results in your secure score going up, making it clear that we're improving our security stance. Okay, that was definitely a lot to take in through the last learning objective. Like I mentioned, security really is job number one here at Microsoft. And we could easily spend a lot more time diving into all the details and the additional services that we have for security, but we'll have to save that for another day. Hopefully, what we've covered gave you enough of an overview of identity, access, and security for now. Let's continue on to our next learning objective on Azure Essentials, cost management. Let's start by breaking down some of the factors that drive costs in the cloud. First, the resource type you choose significantly impacts your expenses. Different resources, such as virtual machines or storage or databases, have varying costs associated with them. It's essential to select the right type of resource that meets your needs without overspending. Next, consumption is a critical factor. Azure operates on a pay-as-you-go model, meaning you're billed based on the amount of resources you consume. Monitoring and optimizing your usage can help you avoid unexpected charges and keep your costs under control. Maintenance also affects costs. Regular updates, patches, and management of resources can incur additional expenses. Automating maintenance tasks and using managed services can help reduce those costs. Geography plays a role in pricing as well. Azure services are available in multiple regions around the globe, and the cost of running services can vary depending on the location. Choosing the right region based on your requirements and budget can help optimize your spending. Network traffic is another factor to consider. Data transfer between different regions or out of Azure can incur additional charges. Minimizing unnecessary data movement and optimize your network architecture can help reduce these costs. Lastly, your subscription type can influence your overall expense as well. Azure offers various subscription plans, including pay-as-you-go, reservations, and enterprise agreements. For example, if you know you need a particular type of resource for, let's say, a year, many resource types offer reserved instance pricing, where you get a significant discount by committing to running that resource for that amount of time. So selecting the right subscription plan based on your usage patterns and business needs can definitely lead to significant cost savings. Another option to help control costs is to shop for services in the Azure Marketplace. The Azure Marketplace is a platform that allows customers to find, try, and buy certified applications and services from hundreds of third-party service providers. It offers a wide range of solutions, such as open source container platforms, virtual machine and database images, application build and deployment software, and developer tools. The Marketplace has over 10,000 listings. And since there are so many applications and services within the Marketplace, there's a lot of potential to find solutions that fit your specific needs and budget, which in turn can lower your overall cost. To help understand the potential costs of services in Azure, we have the Azure Pricing Calculator. It allows you to configure various options to tailor an estimate for your specific needs. The options vary between products, but generally include things like region, tiers, billing options, support options, programs, and pricing offers. It can also include Azure Dev Test pricing, such as for newer services that might still be in preview. It's important to note that the pricing calculator provides estimates and not actual price quotes, since the actual pricing can depend on a number of factors, including the actual usage of the service versus the predicted usage that you used to build the estimate. Also, for enterprise customers, it's possible to view pricing based on any enterprise agreements that you might have. Let's take a closer look at the pricing calculator with a quick demo. All right, so to look at the pricing calculator, what we're going to do is simply go to a URL here. It's going to be azure.microsoft.com, pricing calculator, and let's see how this works. So like I said, this is really about delivering estimates. And so we can scroll down to a list of all kinds of different resources and start adding different things. You'll see virtual machines, storage accounts, lots of things on the left-hand side to filter through all kinds of different services in Azure. So I'm going to start things off with building our estimate. So I'm going to add virtual machines to the estimate here. And it's actually added to an estimate that's towards the bottom of the page. We can jump to it right now, but I do want to add some other things. So let's add a storage count as well. And we could continue on and keep adding like different types of services that I want to get an estimate on. Once we have a couple of things though, then what we're going to do is simply scroll down and we'll see the section on the estimate and we'll see all of the different resources that we've added to it. Now, a couple of things. This is an estimate, right? Like I mentioned, I don't think we need any help right now. It is really dependent on what we set here, right? So this virtual machine, for example, lots of settings, what region it is in the world. We can choose the different regions. Am I using Linux or Windows? What tier I'm using for everything, what type of virtual machines I'm using, so how large they are, and this represents our like full list of virtual machines. How long we're going to use them. So 730 hours is basically a month, right? 30 days. How many of them that we're going to use. And as we sit and play with these settings, our price tag is actually changing, right? It's just a little below this. So you see currently it's at $137.24 a month. We also have things like, the reservations. So we say, hey, I want to use this virtual machine. It's going to be a server in Azure. I want to use this for, let's say, a year. I want to pay this monthly. If we come down a little bit, notice that the price actually drops a little bit. And this is really because I'm using a reserved instance price here. And because I'm committing to, or the idea is I'm committing to a year, that I'm going to receive approximately a 40% discount on everything. There's also things like, the managed disk, the number of transactions for storage that are happening. And these can all add into the full price tag. So the challenge on this is that you really need to know a fair amount about the service before you can come in here and just play with the settings, so that we can have settings that are much more accurate to what your actual use case is going to be. And then, of course, there's the actual usage. So if we do this estimate, but then, real world, we start doing more transactions or working with the service a little bit differently, our costs can change. But this is a really, really good starting point. If we come down to storage accounts, this is the other thing that I added to my estimate. We can see the settings are different because, the service is different. So on a type, blob storage, we can play around with the different types again. Redundancy, these will all change the price tag, what kind of capacity we're going to use, and that's going to be the capacity that we can consume, things like the access tier. And so you can play around with these settings and watch the price tag change for your overall estimate. Now, because I added two things here, I see my total price at $157.79, and something also worth mentioning again is that if you have a licensing agreement, such as enterprise agreement, if you log into this, you'll actually see your enterprise agreements, and the pricing would reflect those prices that are part of your enterprise agreement. So this is basically what the pricing calculator is. You can have a lot of fun with it as far as building out some really good estimates on what you can expect, and you can do this really for any of the services in Azure. So with that, let's jump back into our content and talk a little more.
Another resource to help understand costing is the Total Cost of Ownership calculator. The Azure Total Cost of Ownership, or TCO calculator, is a powerful tool that's designed to help organizations estimate the cost savings they can achieve by migrating their application workloads over to Azure. By entering details about your current on-premises infrastructure, such as the number of servers, storage, and network usage, the TCO calculator can compare these costs to the anticipated costs when running within Azure. The idea is that this comparison can provide a clearer picture of potential savings to help build a business case for cloud migration. The TCO calculator takes into account various factors, including compute, storage, networking, electricity rates, and IT labor costs. And it allows you to adjust key assumptions to better match the cost of your current on-premises infrastructure. The tool then generates a detailed report that shows how savings accrue over time, highlighting the efficiency and cost benefits of moving to the cloud. Let's take a closer look at the Total Cost of Ownership calculator with a demo. Let's go.
All right, so in this demo, we're going to look at the Total Cost of Ownership estimator. And so what we're going to do is we're going to open up a browser. We're going to go to azure.microsoft.com, and then it's pricing and then TCO calculator for the Total Cost of Ownership. So let's open that and work our way through it. Now, this is actually a really large tool because there can be a lot going on to go through and define your total cost of ownership. But what we're going to do to start off with is define all of our current workloads. So this is really our on-premises workloads. And we're going to add things like servers and databases. So I'm going to start up here with a server. We'll work our way down through the page. And what we want to reflect here is a fairly accurate view of what we currently have in our existing data centers, et cetera, for our servers. So we would continue on and say, hey, we have Windows, Linux servers, they're physical servers, so many run Windows. We have maybe 50 different Windows servers. We have a certain size to them, so much RAM, et cetera, probably not 1 gig, but maybe let's give it about 32 gigs of RAM for all those. And we can build these out and keep adding more and more of these
estimate. So I can add another server workload and say, well, we also have a Linux workload. We have, larger servers, smaller servers, and keep adding to this, to our current infrastructure. Working down through the page, things like databases. So what kind of database is it? Is it SQL? Is it things like, Postgres or Oracle? And similar to that, we can fill in all these different settings to really kind of get an idea of how large this environment is. And this is going to really do twofold. One, it's going to help build the estimate for the current environment, but it's also going to help give a bit of an estimate to what this would look like in Azure. Now, there's a big part in Azure about, when we're migrating to Azure anyway, that we want to think about right sizing. And so a lot of the times we do over provision in our on-prem environment that we need to do because we need to have that extra space if we need it. But when we come over to something like Azure, we can actually build in things like auto scaling and all that, so we can do much more on-demand type environments. Storage, right? I'll be fairly quick through some of this. Things like storage, what kind of storage do we have on-prem? I'm going to leave a lot of the defaults here, but I think you get the idea that we can go through and do all the networking and where this is. And then finally, when we get down to the bottom of this, we're going to go next, and then we're going to adjust some assumptions. Now, this is where things also get a little bit interesting, but we need to think about things other than just a hardware to kind of virtualized hardware in Azure kind of comparison, because we do have things like, do we have software assurance on things? Do we need geo-redundant storage? What kind of virtual machine costs might we get? And so we can start playing with certain things and say, hey, no, this is a little bit different. But here's I think where this second level really shines, looking at things like electricity costs, right? Price per kilowatt hour. So what kind of price tag is in your current area for where your data center is. That's going to be a cost to run that data center. Things like storage costs, and this is all again, a lot of your on-prem sort of environment. IT labor costs, what that looks like. One of the things about your IT labor is that if you're maintaining physical servers and everything, we need people to do that within our on-prem environment as well. So, what does that look like? Because when we move over to Azure, we can actually kind of reduce that labor force somewhat, or at least transition it, to other roles. And so there's lots of different assumptions that we can kind of build in here. I'm just going to leave this as the defaults that were there. And then finally, we move to the next page where we can view the report. So the report, in this case, we threw in 50 servers and I left a lot of defaults, but we can look at this over a period of time and say, over 5 years, the estimated cost savings would be, $775,000. We can kind of compare the on-prem costs, as those kind of rise over the years, versus the Microsoft Azure costs, for this. Now, you can definitely get into a lot more detail with this. You can look at it over different times, but I think you get the idea that it's really about comparing these two. And the more information, I should say, the better information that I can provide to this, the more realistic these numbers start to get. There's definitely a lot of detail, real world, but it does definitely paint you a pretty good starting point on what it looks like to migrate from an on-prem environment over to Microsoft Azure. So that'd be pretty good. All right, I think we got the idea here. So we're going to save a lot of money with what I put in here. With that, let's jump back over to our presentation and continue on.
To understand the day-to-day costs of Azure, we have Azure Essentials Microsoft Cost Management. This is a set of tools that help organizations analyze, monitor, and optimize their Microsoft Cloud costs. It's available to anyone with access to a billing account, subscription, resource group, or management group. It allows you to monitor costs proactively with budgets, anomaly detection, reservation utilization, and scheduled alerts. You can also enable tag inheritance and split shared costs with cost allocation rules. Additionally, you can automate business processes by integrating the cost data into external tools by exporting the data.
This can help to maximize visibility and accountability with all of the necessary stakeholders inside or outside of your organization. You can also review tailored recommendations from the Azure Advisor to help optimize costs through reservations, right sizing, and removing idle resources based on your Azure usage. Overall, Microsoft Cost Management is an effective tool that helps you to manage and optimize your cloud costs with transparency, accuracy, and efficiency. Azure Resource Tags. First, what are tags? So tags are metadata elements that you apply to your Azure resources, resource groups, and subscriptions. They consist of key value pairs that help you identify and categorize resource based on settings relevant to your organization. For example, you can use tags to track the deployment environment for your resources by adding a key named environment and giving it a value like production or development. In the context of cost management, tags can play a crucial role. By tagging resources, we can easily group and filter them in cost analysis reports, helping you to understand where your costs are coming from and identify areas for optimization. Additionally, Azure Cost Management uses tags to enable cost allocation. This means you can allocate costs to different departments, projects, or business units based on the tags applied on your resources. You can also use Azure policies to enforce a tagging policy, which will help ensure that all Azure resources are properly tagged when they're provisioned. This approach can help minimize manual errors and ensures consistency in your tagging strategy, which in turn can help with managing your Azure cost and billing. And that brings us to the end of session 5. To recap, in this session, we discussed identity, access, and security in Azure, and introduced concepts such as directory services, authentication methods, and security models. And then we covered the second learning objective on Azure Essentials Cost Management, where we reviewed factors and tools that can be used to better understand and control costs in Azure. That concludes session number 5. Let's take a quick 10-minute break before starting with session 6 on Azure Governance and Compliance, Azure Resource Management, and Azure Monitoring Services. Enjoy your break and see you back soon.
Welcome back from the break, and welcome to our final session in our virtual training day event. In this session, we'll be covering Azure governance and compliance, Azure resource management, and Azure monitoring services. More specifically, we'll start our first learning objective on governance and compliance by introducing Microsoft Purview, followed by Azure policies and resource logs. We'll then discuss the Service Trust Portal before starting our second learning objective on resource deployment tools. In that learning objective, we'll discuss some of the ways we can deploy resources in Azure, such as using the portal, PowerShell, and the CLI. We'll also cover what Azure Arc and the Azure Resource Manager are. And then we'll wrap up the session with our last learning objective on some of the core monitoring tools in Azure, such as the Azure Advisor, Azure Service Health, and the Azure Monitor. Let's get started with our first objective on governance and compliance, starting with Microsoft Purview. Microsoft Purview is a set of solutions brought together to help organizations govern, protect, and manage their data across the entire data estate. It combines the former Azure Purview as well as Microsoft 365 compliance solutions into a unified platform, providing integrated coverage to address data fragmentation, lack of visibility, and the blurring of traditional IT management roles to govern your data assets. One of the key features of Microsoft Purview is automated data discovery. This capability allows organizations to automatically scan and catalog their data assets, creating an up-to-date map of their entire data estate. This map includes data classification as well as end-to-end data lineage, which helps organizations understand where their data is stored, how it flows, and how it's used. Sensitive data classification is another important aspect of Microsoft Purview. It helps organizations identify and classify sensitive information, such as personal data or financial records, helping to ensure that this data is properly protected and managed throughout its lifecycle. End-to-end data lineage provides a detailed view of the data's journey from its origin to its destination. This feature enables organizations to track data transformations, understand data dependencies, and ensure data integrity and compliance. By leveraging these capabilities, Microsoft Purview empowers organizations to gain visibility into their data, safeguard sensitive information, and govern their data seamlessly across on-premises, multi-cloud, and software as a service environments. Azure Policy is a service within Microsoft Azure that helps you create, assign, and manage policies to enforce rules and standards over your resources. It evaluates and identifies Azure resources that did not comply with your policies, helping to ensure that your environment stays secure and compliant. Azure Policy comes with built-in policies and initiative definitions in various areas such as storage, networking, compute, security, and monitoring. These built-in definitions make it easier and faster to get started. But you can absolutely make custom rules and definitions to enforce your own standards for your organization. Azure Policy rules and definitions can be configured to assess your environment through reporting non-compliant resources, or those rules can be configured to block non-compliant resources from being created, or block resources from being modified into a non-compliant state. It also provides a compliance dashboard that offers an aggregated view of your overall compliance state, allowing you to drill down to specific resources and policies, helping you to quickly identify and remediate non-compliant resources so that you can remedy them. Azure Resource Locks are another crucial feature in Azure that helps prevent accidental deletions or modifications of critical resources. They act as an additional layer of protection, ensuring that specific resources remain secure and are not inadvertently altered or deleted. There are two types of locks: cannot delete, also referred to as a delete lock, and read-only locks. The cannot delete lock allows authorized users to read and modify a resource, but they can't delete it. On the other hand, the read-only lock permits users to read a resource but prevents them from deleting or updating it. When you apply a lock at a parent scope, all the resources within that scope inherit the same lock. This means that even resources that you add later will inherit that parent lock. Also, the most restrictive lock in the inheritance takes precedence. For example, if you apply a read-only lock to a resource group, all resources within that group will inherit the read-only lock, ensuring they cannot be modified or deleted. Let's take a closer look at managing resource locks with a quick demo. All right, so in this demo, we're going to look at resource locks. So we already have some resources available. So I'm in the portal, the Azure portal. So let's go over to our resource group where we've created a few resources at this point. And we can do this with a lot of different resources. We see there's a bunch here. But what I'm going to do is I'm going to play with the storage side of it. But I'm going to change the lock on the resource group. So think, where all these resources kind of exist. So under settings, we can come down a little bit to locks. And right here, I'm going to add a lock to the resource group. And remember that when we do this at the scope level, let me get a lock name in here. We'll call this, demo lock. Hopefully you have better names on this for real world. This is going to be a read-only level lock. And keep in mind, when we set this, we're actually setting it on the entire resource group. So all of the resources in it are going to have the same lock applied. Since it's read-only, we will not be able to make any changes. So jump in really quick. Let's go back to one of the resources to that storage account. And let's go try and make a change. So let's do something pretty trivial. Let's see. Let's just go to containers, and we'll try and make a brand new container in here. All right, so just put something in there. It doesn't matter, like test or something. Sure, that works for me. And let's hit create. And what do we get? We get an error. I said, hey, failed to create it. Basically, it cannot perform it because the following scopes are locked. Please remove the lock. Now, I'm the administrator in here. I have administrator access to all of this, but the lock still blocks what I can do in here. So if I need to make any change or anything, what I actually need to do is go and remove that lock first, and then I'll be able to go and do the changes. So it's pretty easy though. You go back into locks, and I'm just going to refresh this. I just made it so it wasn't showing up. And I'm going to take this lock, and notice there's a delete way over on the right-hand side. Go ahead and remove this. All right. And just so you see, it's not a refresh problem now. It is in fact gone. And at this point, if we go back and go to make a change, we absolutely could, go and make any of the changes to the content. So that's resource locks. Let's go back to our content and continue on with our course. The Azure Service Trust Portal is another important resource for anyone looking to understand how Microsoft ensures the security, privacy, and compliance of its cloud services. The Service Trust Portal provides access to information like audit reports, compliance guides, and white papers. And these resources can help users understand how Microsoft Cloud Services protect their data and how they can manage cloud data security and compliance for their organization. One of the key features of the Service Trust Portal is its ability to provide detailed information about Microsoft's compliance with various global, regional, and industry-specific standards regulations, such as ISO, IEC 27001, SOC 1, SOC 2, and SOC 3, as well as compliance with GDPR and other privacy laws. Users can access the Service Trust Portal with their Microsoft Cloud Services account. And once logged in, they can download audit reports from Microsoft Services produced by external auditors. The portal also offers tools and resources to help organizations perform risk assessments and manage their compliance efforts. For example, the Compliance Manager tool within the portal provides a dashboard that helps organizations track their compliance status and manage their compliance activities. Next up, resource deployment tools. When working with Azure, you can use a variety of tools to help manage and interact with your resources.
The Azure portal is a web-based interface that provides a graphical way to manage your Azure resources. It's user-friendly and allows you to perform a wide range of tasks, from creating virtual machines to configuring networks, all through your web browser. For those who prefer command line interfaces, the Azure Command Line Interface, or CLI for short, is a powerful tool that allows you to manage Azure resources using simple commands. It's available on Windows, Mac OS, and Linux. The Azure CLI is particularly useful for automating tasks and managing resources at scale, all using the command line. Another command line tool is Azure PowerShell, which PowerShell was originally designed for Windows, but has been available on Mac OS and Linux for quite a while now. Azure PowerShell provides commandlets for managing Azure resources directly from PowerShell command line. It's a great tool for those who are already familiar with PowerShell and want to extend their skills to manage Azure resources in particular. Both command line tools can be run inside of the portal by using the Azure Cloud Shell. This is a shell environment that is hosted directly in the Azure portal interface, and it has the advantage of having all the necessary software installed in it to run Azure CLI or PowerShell commands without having to install anything on your own computer. The Azure Resource Manager, or ARM for short, is the deployment and management service for Azure, and enables you to create, update, delete resources in your Azure account. So when you send a request through any of the Azure APIs, tools, or SDKs, the Resource Manager is what receives the request, authenticates and authorizes it, and then forwards it to the appropriate Azure service. This ensures that you see consistent results and capabilities no matter which deployment tool that you're using. One major difference about provisioning resources in the cloud is that we can deploy all of our infrastructure as code. What we mean here is that things like networking, virtual machines, and security layers like firewalls and routing can all be created and managed by using code rather than the traditional method of needing to deploy physical assets like cabling. This can help to ensure consistency between environments, and it can give you the ability to implement and manage large environments very rapidly compared to implementing on-premises infrastructures. Another important aspect of ARM is its support for declarative syntax through what are called ARM templates. These templates are JSON files that define the infrastructure and configuration of your Azure resources. They allow you to deploy, update, and delete resources in a consistent and repeatable manner. As well, the same templates can be used for different environments such as testing, staging, and production, which would help to create resources between environments consistently. If you think about all of the layers that go into a deployment, these templates can target different layers of your solution. For example, you could create the infrastructure using templates, or by using something like the Azure CLI to issue CLI commands. And then you could have a different template that deploys all of the resources needed to host an application on top of that infrastructure. That way, we can manage these resources separately or together as needed. And they can all be part of a larger orchestrated deployment very easily using an assortment of tools. One way to create ARM templates is by using Bicep. Azure Bicep was created as an abstraction layer over ARM templates to help provide a more concise and readable syntax for defining Azure infrastructure over using ARM templates directly. Bicep files are written in a more human-readable format, which makes it easier to understand and manage your infrastructure as code. This is particularly beneficial for those who are new to infrastructure as code, or those who do find JSON-based ARM templates a little bit big and cumbersome. Ultimately, Bicep files get translated into ARM templates under the hood, so Bicep still has all the functionality that exists with ARM templates. In the slide here, we have an example of a Bicep file. It's short and to the point. In this example, we're creating a new storage account and configuring it as a local redundant storage with a default access tier set to hot. Let's compare that to the JSON template, the ARM template. This is an example of the same resource being created by an ARM template, which uses JSON syntax to declare all of its settings. Even though it's just a single resource, it's quite a bit larger to the point we can't fit it all in the same slide. We only see the first half. And now we see the second half. All that to create the same storage account that's going to use local redundant storage and have a default access tier set to hot. As you can tell, between the example of the bicep file versus the ARM template, bicep files are definitely easier to create and manage. Azure introduces a lot of new tools for organizations to manage resources. For many organizations, it can be challenging to manage Azure resources with Azure tools, and then turn around and use a different set of tools to manage their on-prem resources. So to help with this, we can use Azure Arc. Azure Arc is a set of technologies that extends the Azure platform to manage and govern infrastructure across on-premises, multi-cloud, and edge environments. It can provide a consistent management layer, allowing you to manage your environment, both Azure and on-prem resources, for example, as if it were all running in Azure. With Azure Arc, you can project your existing non-Azure resources into the Azure Resource Manager, enabling you to manage virtual machines, Kubernetes clusters, and databases as if they were actually running in Azure, but they're actually running in your on-prem environment. The big feature of Azure Arc is really in its ability to provide a unified management experience. This means that you can use familiar Azure services and management tools regardless of where your resources are actually located. Next up is our last and final learning objective on some of the core monitoring tools in Azure. First up is one of our Azure essentials, the Azure Advisor. Azure Advisor is a personalized cloud consultant that helps you follow best practices to optimize your Azure deployments. It analyzes your resource configuration and usage telemetry, then provides recommendations to you to improve the cost effectiveness, performance, reliability, and security of your Azure resources. When you access Azure Advisor through the Azure portal, you'll find a dashboard displaying personalized recommendations for all of your subscriptions. These recommendations are divided into 5 categories: reliability, security, performance, cost, and operational excellence. For example, reliability recommendations help ensure and improve the continuity of your business-critical applications, while security recommendations help detect threats and vulnerabilities that might lead to security breaches. Azure Advisor also helps to connect you with tools and resources to help you take action on these recommendations. You can apply filters to display recommendations for specific subscriptions and resource types, and select a recommendation to learn more about it. Often, recommendations provide an advisor quick fix option that allows you to remediate recommendations with just a few clicks. Overall, Azure Advisor is designed to help you save time on cloud optimization by providing actionable recommendations that improve the performance, security, and reliability of your resources, while also identifying opportunities to reduce your overall Azure spend. If something isn't working, one of the first questions we want to answer is it a problem with my service configuration or solution implementation? Or is it a problem with maybe the underlying service in Azure? So to help answer that, we have Azure Service Health. This is a collection of services that are designed to keep you updated about the status of Azure services, as well as filtered views that help you focus on just your services or individual resources that might be affected by a service issue in Azure. You can view the overall Azure status of all services in all regions globally. You can also view the status of specific services within regions for service types that you've deployed. Basically, if there is an issue with a particular region for a particular service, but you're not using that type of service and you're not using anything in that region, you won't see the issue, which is fine because it doesn't affect you anyway. That way you can focus on issues that are actually having an impact on your services. And lastly, You can also view the resource health, which is a filtered view of issues that may be impacting your resources specifically. By reviewing Azure Service Health, you can more quickly determine if the underlying issue is a Microsoft responsibility or yours. Last but not least, Azure Monitor. Azure Monitor is a comprehensive monitoring solution designed to collect, analyze, and act on telemetry data from both cloud and on-premises environments. Azure Monitor collects data from various sources, such as applications, virtual machines, containers, databases, networking components. And then the data is stored in a common data platform, allowing you to correlate, analyze, visualize, and respond to that information. One of the key features of Azure Monitor is its ability to provide deeper insights into the health and performance of your resources. For example, Application Insights helps you detect and diagnose issues across applications and its dependencies, while Virtual Machine Insights and Container Insights allow you to deep dive into virtual machine or container-based issues. A core component of Azure Monitor is Log Analytics. Log Analytics enables you to store and manage log data for your entire organization, allowing you to drill into your monitoring data for troubleshooting and deep diagnostics. Azure Monitor helps you collect all that data from monitored resources, as well as query and visualize the log analytics data in the Azure portal. Azure Monitor also supports automated actions to help manage your resources at scale by implementing what are called alerts. Alerts allow you to create rules for different conditions and specify an automated response for those conditions. This would allow you to be more proactive in responding to issues or events in Azure. You can also create more permanent visualizations with Azure dashboards and workbooks. For example, you could create a dashboard that is focused on monitoring all of the core services for an application that you've deployed. Azure Monitor also integrates with other Microsoft and non-Microsoft tools, allowing you to export monitoring data to third-party systems for further analysis and visualization. Overall, Azure Monitor really is a comprehensive monitoring solution for Azure resources. This brings us to the end of this session, where we covered governance and compliance, resource deployment tools, and discussed some of the monitoring options in Azure. And that concludes our Microsoft Azure Virtual Training Day on Azure Fundamentals. Let's recap what we've covered. In part 1 of our course, we started with our first session where we covered cloud fundamentals. Then we discussed the Azure architecture and Azure compute resources in our second session. In session 3, we introduced Azure networking. Then in part 2 of our course, we covered Azure storage in the 4th session of our course. We then discussed identities, access, and security, as well as cost management in session 5. And then we finished things off with this session, session number 6, where we covered Azure governance and compliance, Azure resource management, and finally, we introduced Azure monitoring. Thank you for attending this Microsoft Azure Virtual Training Day, Azure Fundamentals course. Remember, there are many ways to continue your learning journey. Check out Microsoft Learn at https://aka.ms/learn for a variety of self-paced learning options that are all available to you. Happy studying. Cheers.